Oh, professor, yeah, mute.
Reminding me of this, I thought I unmuted this once. Thanks. So I can repeat the last two sentences. So now we're going to see the linear span or linear combination. And the linear combination, it is defined as such that for any vector v1, v2, vn, and for values of c1, c2, cn, c1, v1 plus c2, v2 plus cn, vn, which is also which can be also represented as ci vi. This is called a linear combination. Is called a linear combination of all vi's and denoted as like this: linear v1, v2, vn. Okay, so this is called the linear combination of the specific vectors. So in the previous session, we saw how the columns of the matrix A can constitute the range, or they constitute the whole range of a matrix A. And this range of matrix A, we remember that this was, for example, let's provide an example here: 1 minus 1, 2, 2, 3, 4, and the range of this matrix A, so we can call it like this: the range of A is equal to what? Is the linear combination of the first column and the second column. So the first column here, C1, this is equal to 1 minus 1, 2, and the second column, C2, this would be equal to 2, 3, 4. So here, the range, actually, the C, we can write this like this: range is equal to alpha 1 C1 plus alpha 2 C2, or this is equal to the limit of C1 and C2. So this is the linear combination. Now, so if we have a look at this matrix A, what is the range of matrix A? The range of matrix A, this is a linear combination of 1, 2, and 3, 6. And let's have another matrix, B, which is 1, 2, and 2, 4. Now, the range of B, this is the linear combination of 1, 2, two, 4. Is there any comment you can have here for this example?
We can express column 2 as 2 times column 1.
Yes.
So the range is only the span of the first column.
That's true. So we can simply say, that is correct, we can write this one that this is in fact linear combination of 1, 2. And this is also equal to the linear combination of the vector 1, 2. So then, as a result, we can say that the range of matrix A, this is equal to the range of matrix B. So why is this the case? Because the second column, it is linearly dependent with the first column. So we are not adding any new fundamental new information. So this is the linear combination, and other than this, we can let me see. I wonder if we can go over a couple of examples. Okay, let's see this example here. Wait a moment. So can you find B1 and B2, which means that can you find any vector? Give me a couple of examples so that B1 and B2, they are in the range of A. Can someone give you such an example? So in order to be in the range of A, we are expecting these vectors to be expressed as a linear combination of the columns of A. So we can
have 0, 5, 1.
That's correct. 0, 5, 1. Can you give me another B2?
-2, 1, -1.
Is this right? How did you get the -2? You did twice the second?
No, I get minus the first column plus the second column.
Okay. Okay, so you did this and we get -2, that's correct. And then, but this is -1, the second one, right?
Yeah, I'm wrong.
Okay, and then -1 plus 0. Okay, this is enough. What about B3? But we want the B3 which is not in R8, in the range of A.
-2, -1, 7.
-2, -1, 7. How are you sure? How did you get this?
There is not a linear combination that can get us to this vector.
But how do you know? Did you check it?
No, I didn't check it, but I'm sure.
Okay. Okay. Then if you are sure, then let me give another example. But we are not done here. Okay. We'll come back to this problem. Let's assume that we have a matrix A, which is 1, 3, -1, 2. Okay, I'm just cutting down one row. Well, let's consider this one A. Sorry, no, let's give this A. Let's give this A1. Now, you give this answer -2, -1, 7. Can you find the vector B1, which is in the range of A1?
Zero, 5.
That's correct, 0, 5. then can you give me a B2 which is not in the range of A1? This is an element of our A1, okay? But now we want a B2 which is not in the range of A1. Give me two numbers.
0, 6.
Are you sure 0, 6 is not here? How do you know that 0, 6 is not in the range of A1?
Because to get the first element 0, I got the sum of both columns. And if I get the sum of the second row of both columns, I don't get 6, I get 5.
Well, you know, let's check this one in a step-by-step procedure. Okay, let's try to solve this one carefully, which means that wait a second. So how can we check whether the B is in the range of A1 or not? How can we do that? We do the reduced row echelon form. We try to solve the equation, right? This is the best approach. And to do that, we would have the following. We have here 1, 3, minus 1, 2, and here we have 0, 6. And let's try to get the reduced row echelon form. What is the next step? We keep the first row the same, 1 minus 1, 0. And then what do we do here? We do
minus 3 row 1.
That's correct. Minus 3 row 1, which makes this 0. And then this is 2 plus 3. This is 5, and then this is 6, right? What should we do next? We can make this a 1, right? How can we make this 1? We can do row 2 divided by 5, right? And here we get 1 minus 1, 0. Here we get 0, 1, 6 over 5. What is the next step?
To make the top element.
Okay, so we do this one. We say that row 1 star, this is equal to row 1 plus row 2, right? If we do this, then row 2 is not going to change. We have 0, 1, 6 over 5, 0, 1, 6. What is 6 over 5? 1.2, right? Let's write this one, 1.2. And then we have row 1 plus row 2, this is 1. 0, and the other, this is 1.2 also, okay? So what do we learn from here? We see that x is equal to 1.2, and y, this is equal to 1.2, right? So it looks like we do have a solution for this. I had a problem, step-by problem. How can we test this one? Well, let's come here, and let's do the following. 1.2 times 1,3 plus 1.2 times minus 1, 2. Okay, this is equal to, what is the first row, the first element is 0. That is correct. What about the second element? We have 1.2 times 3 plus 1.2 times 2. What is it? 6. So apparently, this B2 that you just gave to us, this is in fact in the range of A1. Okay, so this statement, in order so the viewers don't get confused, this is not true. We thought it was true, but apparently this is an element of that. This is in the range of A1. So you came up with something random, or maybe you tried to use some logic in there, and you also came up with this. So can you now? It looks like we were not correct when we proposed this one to be an element not in the range of A1. So how do we check for this then? What can we do here? We follow the same solution as in here, right? Shall we do that? Yes, we can. If Obama can do that, we can also do that. So we can try to solve this one. But actually, I want you to think for a moment. Why is it possible? Why was it difficult for us to figure out or to come up with a combination of numbers that constitutes B2 according to our requirement? Ce-ți două, che pe G, Still appreciating.
Can we say that it's a square matrix and the determinant is different from 0?
I cannot hear you. Probably the friends in the class also don't hear you exactly. Can you say it again?
As A1 is a square matrix,
Yes.
and also the determinant is different from 0.
Now this is a very strong argument, yes, and then?
We can say that it's always consistent.
That's correct. It is always possible to find...
Always a unique solution for every B.
Yes, here we have 2 by 2 matrix times x, which is 2 by 1, is equal to b, which is 2 by 1, and this is a square matrix. That is true. And this square matrix, it has determinant different from 0. Is it so? It is, because the determinant is 2 plus 3, 5. So determinant here is equal to 5. And this is, okay. So we can always find a solution. Now, another argument that we can put here, which is also very intuitive, is the following. We have 2 vectors in 2-dimensional space which are not linearly dependent. If we have 2 vectors which are not linearly dependent, they are at specific angles. Okay, so we have something like this. If we have these 2 vectors on the board pointing like this, we can define any point on the whiteboard using these 2 vectors. We can change the angles a little bit. It's not a problem, but we can define any point. So I was pretty sure that since we have here 2 vectors, 2 by 1, we can span the complete R squared. This should be in that range of that A1. So even if I make other vectors such as minus 11 plus 73, this one also is in the range of this one, okay? Why? Your friend in the class, she gave a very good answer. She said because the determinant of A, it exists, which means that the inverse exists. So this has always a solution. But a more intuitive approach, it could be the following. We have a 2-dimensional space, we have two independent vectors, then we can do anything with it. But now when you come here, we have 2 vectors in 3-dimensional space. Let's look at this vector. This is 3 by 1, okay? So if we had a third vector here, so we can compose another matrix. Let me write it this way. Let me write it like this. Let me have A2, which is equal to 1 minus 1, 2. Then let me multiply this by 2. 2 times 1, this is 2, minus 2, 4. But I don't want it linearly dependent. Let me make this 3. Okay? And then let me add this to 1 plus 2, this is 3. This is minus 3, 5. I don't want them linearly dependent. From 5, I made it 4. Now, most probably, I didn't check. We have to check it. Most probably, the determinant of A2 is different from 0. It is worth checking, actually. Wait a second. No, we ended up... Oh, I was trying to make something beautiful, but it looks like the first row is negative with the second row. Do you see that? How did it happen? I multiplied by 2, I added them. Okay, I got this. No. Apparently, we need also to change a little bit here. So, okay, so it was like this. Then, determinant of A2 in this format is 0. Determinant of A2 is equal to 0, which means that we don't have 3 vectors. We have 2. We might even have 1, which means that they are linearly dependent with respect to each other. So we could not do a good job into finding the determinant to make it different from 0. Let me keep it like this. But in case we can determine a matrix A3, 3 by 3, whose determinant is different from 0, then you can come up with any vector, and it is always going to be in the range of that matrix A3. Now, when it comes to this value, I could propose the following. In order, so this one we don't know. You can check this as a homework whether B3 is in the range of A or not. A possible choice could be the following. Let's add B1 and B2. What is it? B1 plus B2 is going to be minus 2 for 0. So this is equal to B1 plus B2. But if B1 is in the range of A, B2 is in the range of A, this is also going to be in the range of A. So for this one, we just change a little bit one of the entries. I make this one. We have a chance for B3 not to be in the range of A, because this was B1 plus B2 plus some vector, which I did like this, 0, 0, 1. When кое-что не constante, не причем at a linear independence, okay? So we just add that number, and we have a chance which we need to confirm. Okay, so now let's check this value that I came up, or we can even do this. I mean, we need some time to do this, so which part of the board can I use? Let me use this one. Okay, 1 minus 1. Let's write the matrix A. 3, 2, 1, 0. And here we have the other, what was this? Minus 2, 4, 1. Minus 2, 4, 1. Let's follow step by step. We have 1, minus 1, 2, 3 minus 3, 0. This is 5. Is it? Check if I make any mistake. 3 plus 2, 4. Minus 6, this is 10. Then this is 1 minus 1, 0, 1, 3. And 5, 10, we can write this one as, let's not skip any step. So this is 1, minus 1, 2, 0, 1, 2, 0, 1, 3. It looks like, let's see, it looks like it doesn't have a solution. Then this is a leading one, we need to make this 0. From here, we move this way, and we get, wait a second, 1, minus 1, 2. Can you follow? 0, 1, 2. To make this 0, we do row 3 minus row 2. This is 0, 0, 3 minus 2. This is 1. What can we say at this stage?
It does not have a solution because
That's correct.
x0, x2, 0.
It doesn't have a solution because at the lower part we have a component which says 0, 0, 1, which means that 0 times x plus 0 times y, this should be equal to 0 and not equal to 1. So at this part we say no solution. So apparently, to get no solution, this thing worked. How did we do it? We added the two elements which were in the range, which you helped me to define these. And now I made a linear, so this part is linear combination, so B1 and B2 is in the range of A, but B1 plus B2 plus a little bit of non-linearity. It's not non-linearity in the general sense, but it makes it linearly independent. Okay, that's what we want to say. So, do we understand this part now? But what is very useful or very essential is to think about, so we can even have 4 vectors in the 4-dimensional space, which can constitute a matrix 4 by 4. We find the determinant, if the determinant is equal to 0, sorry, is different from 0, then any quadruplet, any pair, not pair, any a set of 4 numbers, that means that you can describe it with the columns of this 4 by 4 matrix A, whose determinant is different from 0. Okay? Now the concept of vector spaces, it helps us to determine, even to understand this concept that we just went over here, this helps us to understand even when a 2-dimensional space is correctly spanned by a set of vectors, or when 3-dimensional space does the same, and so on. Let's see an example. Okay. Okay. So let's assume we have a 3 by 3 matrix. 1, 2, minus 1, 0, lambda, 1. So here we have a 3 by 3 matrix, and we have one number which is different from, which is undefined yet, which is just lambda. And let's assume that we have also a vector b, which is the answer vector, 2, 7, mu. And the first question is the following. Find for which value of lambda we have a unique solution. For which lambda value of lambda we have a unique solution. So to answer this, what should we check for? What can you say?
If AX is equal to 0.
Teddy gave a valuable answer, so we have to check for the determinant. But you said AX is equal to 0, you said?
Yes, that's what I said, to have a unique solution.
So the first option, we say that AX is equal to 0. So if we have a unique solution, now if we write this like this, we can, what will be the X? This stays, okay, let's give this as an option. This does not look very profitable or very useful. But we had another suggestion by Teddy, who said that we can check the determinant of A. What is the determinant of A? Can you answer this, Teddy?
That's okay. 1 lambda minus 1 1.
Yes, and then?
Minus 2.
Yes.
5 lambda 1 1.
5 lambda 1 1.
0.
And then? Yes.
Plus 0. 5 1 1 minus 1.
Okay, and this is equal. What is the determinant here?
1 plus lambda.
Okay, what is the determinant here?
5 minus lambda.
5 minus lambda. So the determinant then it's equal to 1 plus lambda minus 2 times 5 minus lambda. What is this, all of it?
1 plus lambda minus 10 plus lambda. Okay,
Is this something like this? Does this look good? Attended? Lambda should be different from 3. Yes, that's correct. So in this case, the determinant, when lambda is equal to 3, we get the determinant is equal to 0. We don't want this, we want the opposite. So this means that this implies that lambda different from 3 gives us unique solution, provides or helps us provides a unique solution. Okay. Then the next question, we can ask the following. For which lambda and mu system has no solution? For which lambda and mu we have no solution. So how can we approach to this problem now? First of of all, it looks like when lambda is different from 0, we get a unique solution. So we have so we just need to exclude lambda equal to 3. So let's look for a moment. This is the values of lambda. Okay, this is 0. This is 1, 2, 3. In all the space of numbers from minus infinity to plus infinity, we just need to exclude this. Okay, take this out, you are good. But now we want to look at the condition or to a specific case when we have no solution at all. So what do we get in this case? It looks like we have to exclude, we have two options, right? So let's have a look here. I get a comment here, lambda is equal to 3, mu is equal to 1. Okay, I got here an answer. Let's try to solve this one, Teddy. So if we pick up the second option, we get a unique solution. If we pick up the first option, where determinant is equal to 0, so determinant is equal to 0, we can say we could have no solution at all, okay, or infinite number of solutions. So we have this. So we are going to check carefully what happens with these two possible options. Then, I was trying to write this one here. We can take that away. And let's try to find the general solution of this problem, which means that we have here 1, 5, 1, 2, 1 minus 1, 0. Now we are going to consider the first case where lambda was 3. Okay? Because if we put instead of lambda any other number, we are going to have a unique solution. This is 1. And then we are going to have the answer vector, which will be augmented here like 2, 7, and mu. Then let's try to get the reduced row echelon 4. So we move forward. This is 1, 2, 0, 2. Then this is 5 minus 5. Then this is 0. 1 minus 10 minus 9. 3 minus 5. This is 3. Then 7 minus 10 minus 3. Is this correct? So minus 5 minus 10. Yes. Then to get this 0, we get row 3 minus row 1. This is 0 minus 3, 1, mu minus 2. Mu minus 2. The next step, what can we do? In the next step, we have 1, 2, 0, 2. We can divide by 3. Okay? Let's divide by 3 here. We get 0. Or let's divide by minus 3. Let's divide by minus 3. And we get here 3 minus 1, 1. And the last row, we get here 0, minus 3, 1, mu minus 2. What can we do in the next step? We can add the second row with the third row. Yes, Ray, we can do that. Yes. 1, 2, 0, 2. And then here we have 3 minus 1. Sorry, no, this is wrong. And then let's add row 2 with row 3. We get here 0, 0, 0, mu minus 1. So let's see this last row. We know that, what do we understand from here? We have solution. We have an infinite number of solutions for mu is equal to 1. Okay? So if mu is equal to 1, we have infinite number of solutions. But if this is not the case, then we have no solution. No solution for mu different from 1. Okay, so this is the answer. And then comprehensive analysis or complete analysis of the case is the following. If we put here lambda And if we assign here mu, we have the two-dimensional space where we can pick for different values of mu and lambda. And it looks like here we have 1, 2, 3. So this point, so when lambda is equal to 3, what is lambda equal to 3 is this line. So 1, 2, 3. Okay. So if we stay, wait a second. If we stay anywhere in this diagram, except this red line, we have a unique solution. Okay, so we have a lot of space where we can provide good answers. But then let's look at these cases. When lambda is equal to 3, when we are on this line, we have here 1. When mu is equal to 1, we have an infinite number of solutions. So right at this point, we get this. Infinite solutions. Then where do we have no solution? We have no solution if mu is different from 1. So we have this, let's consider this double red line. So we have no solution over the double red line. We have an infinite number of solutions right at this point 3, 1. And we have unique solutions anywhere other than lambda equal to 3. So stay away of the red line and you get a unique solution. You stay on the red line, mu equal to 1, we get infinite number of solutions. Then the double rail line, that has it is considered when we have no solution. Okay, so this was another example. Meanwhile, do you have any question or anything which is not clear? Now, today we're going to have a quiz. Do you have any question? Ray, you wanted to ask something?
Sa pyetje kemi në quiz, profesor?
Kam përshtypjen 4 ose 5. Jam diçka po e shikoj edhe një versionin e fundit. Kam përshtypjen 5 pyetje mund të keni, 5. Do pyetje tjetër?
Sa minuta të zgjatë?
Diku te 35 minuta.
Okay.
A do jetë mësimi sotëm apo vetëm ato që kemi marrë?
No, the today's lecture, mësimi sotëm nuk do përfshihet, jo.
Okay.
Profesor, pyetjet do jenë me shtjellim apo alternativa?
Pyetjet do të zgjedhim alternativa, por ato fletat të cilët e keni zgjedhur pyetjet do ja plotoni në fund të quizit. Mirë. Dhe I bëni foto çfarë keni, edhe fotot ju lutem mos përdorni rezolucionin më të lartë mundshëm që ka celulari, se nuk është se të shkojmë diçka shumë të detajuar, por bëni një foto fletës së quizit dhe siç përmendëm pak sesionin e mëparshëm, tham që për të gjatë quizit do qëndrojmë larg kamerës, që kamerat na shikojnë ndërkohë që ne po punojmë. Mirë.
Në rregull.
Okej. Tjetër, kam një pyetje tjetër?
Për pjesën e kohës, 35 minuta mjaftojnë?
Unë mendoj që mjaftojnë, po. Me fjalë, do e shikoj edhe një herë, do e konsideroj edhe një besoj se mjaftojnë. Kështu që për 35 minuta do bëni quizin, do shkoni pastaj do bëni qef. Mirë. Ose do I thoni dhe shokëve, ishte shumë I lehtë, ishte element quizi. Okej, këtë sesionin e dytë po e mbyllim këtu ne.